In this question, we have a GP mixed within an AP. The terms 1, 2, 4, 8, and so on form a GP, and they are arranged such that in the first row there is one term, in the second row there are two terms, in the third term there are three terms, and so on. The number of terms in each row therefore form an AP. We can see that for the first term in the second row, there is one term before it. For the first term in the third row, there will be 1 plus 2 terms before it. Therefore, by this logic, we know that by the nth row, there will be 1 plus 2 plus 3 all the way until n minus 1 number of terms before this term. For the first term in the second row, its position in the GP will be 1 plus 1. For the first term in the third row, it will be 1 plus 2 plus 1. And therefore, in the nth row, the first term's position in the GP will be 1 plus 2 plus 3 all the way until n minus 1 plus 1. To find out any term within a GP, we simply have to use the formula Tn equals to AR n minus 1. And for this GP, we know that A, which is the first term, is equals to 1. R, which is the common ratio, is 2. And N, the position of the term in the GP, is going to be equals to 1 plus 2 plus 3 all the way until n minus 1 plus 1. And we know that 1 plus 2 plus 3 all the way until n minus 1 is actually an AP, which we can then apply the sum of a AP to obtain what is the simplified value. And this gives us n minus 1 over 2 times n plus 1. Substituting all this value in, we can then obtain the value of the first element in the nth row to be equals to 2 to the power of n squared minus n over 2. In part B, we are asked to find the sum of all the elements from the 10th row to the 20th row. And thus, the first thing we need to do now is to find out the sum of all the elements in the first n rows. The sum of all the terms in the first n rows can be found using the sum of a GP formula, A times R to the power of n minus 1 over R minus 1. We can then make appropriate substitutions where A is equals to 1, R is equals to 2, and n is equals to 1 plus 2 plus 3 all the way until n. We realize that the terms in the power is actually the sum of an AP, 1 plus 2 plus 3 all the way until n. And therefore, we can change this sum into n over 2, n plus 1 using the sum of an AP formula. Thereafter, to find out the sum of all the elements from the 10th row to the 20th row, we simply have to take the sum of the first 20 rows minus the sum of the first 9 rows. Substituting n equals to 20 and n equals to 9 into our previously found formula, we can then simplify and reduce our sum of the elements from the 10th to the 20th row to be 2 to the power of 210 minus 2 to the power of 45.